In the previous video, we tackled a problem involving an algorithm with sequential statements. Specifically, we explored how to calculate the surface area of a cylinder based on user-provided inputs for radius and height. We began by identifying valid inputs, outlined a step-by-step process for determining the surface area, and then displayed the output. Our solution was represented using pseudocode and a flowchart. Subsequently, we translated the algorithm into a Python program, utilizing Python objects or variables, arithmetic expressions, and input-output operations. Additionally, we touched upon essential programming practices like naming variables to enhance program readability. In this video, we will review the form of selection statements and we will discuss Boolean expressions. If you are well versed in Boolean expressions, as well as logical and relational operators, feel free to skip this video and proceed to the next topic. Before going to problem solving, let's refresh our understanding of selection or conditional statements and explore essential concepts related to conditions. In a conditional statement, an evaluation of a condition precedes the execution of specific statements if the condition holds true. A condition is an expression that results in either true or false, known as a Boolean expression. Typically, conditions entail the use of logical and relational or comparison operators to determine their truth value. Here are the comparison operators that we have already discussed in one of the previous videos. We can use expressions that use comparison operators in conditional statements. Moreover, we can have complex conditions by combining expressions with logical operators. These are the logical operators that we have discussed. The not operator negates the Boolean value of an expression. If the expression is true, then it becomes false and vice versa. The AND operator returns true only when both expressions are true. The OR operator returns true if one or both expressions are true. The and or logical operators are used to combine two valid conditions. For instance, when determining if x is the largest among x, y, and z, expression x greater than y and z is not the correct way to write this comparison. The correct approach is to compare x to y and x to z separately. The accurate expression should be x greater than y and x greater than z to determine if x is the largest among the variables x, y, and z. When assessing expressions containing both comparison and logical operators, it is essential to adhere to a specific hierarchy. The evaluation sequence typically involves resolving expressions within parentheses first, followed by comparison operators and then logical operators. Here's an example of evaluating a complex expression with condition and logical operators. Let's say we wish to evaluate the expression given that x equal to 7, y is equal to 9, and z is equal to 2. We follow the hierarchy when evaluating the given expression. First, we evaluate the conditional expressions from left to right. X greater than y is false. X greater than z is true, but x less than 0 is false. Then we evaluate the logical expression and true and false is false. And finally, the OR logical expression. So the result of evaluating this expression, given the values of x, y, and z is false. These concepts are crucial for solving problems that entail conditional statements. In the upcoming video, we will address such problems by designing algorithms, illustrating them with flowcharts and pseudocode, and converting them into Python program codes.